This video is for mile marker 2, practice 1, questions 9 and 10. Questions 9 and 10 are really similar. They're both asking you to identify a transformation. So before we get into the actual questions, let me point out a few things. First of all, you really need to be specific here. It's not sufficient to tell me that it's just a translation, rotation, reflection, or dilation. So let's be really clear about what information you need to give me. If the transformation is a translation, you need to tell me the distance and direction. If it's a reflection, in addition to telling me it's a reflection, I need to know over what line the pre-image was reflected to create the image. For rotations, I need a degree, a direction, and a center of rotation. For a dilation, a scale factor, and a center of dilation. Now, as you work through the mile marker practices, I think you'll notice that a lot of these rotations and dilations are about the origin, so that should make it a little easier to identify, but don't make the mistake of not including that in your response. All right, so let's take a look at question 9. If you take a look, we've got to be really careful that we recognize which is the pre-image and which is the image. And the way to tell is to look for the prime symbols. So when I observe that the triangle to the top left is marked with A prime, B prime, and C prime, I know that that's the image. And remember, the image is the one that comes second. So I might even want to notate somewhere. I might say like pre, and then I might say image, or just something so that I know that this was the original over here, that this is our original. All right, next we want to identify whether it's a translation, reflection, rotation, or dilation. So keep in mind, a dilation will be, we'll notice a change in size, so it'll be larger or smaller. A rotation would be a change in orientation. A reflection is also a change in orientation, so you have to be kind of discerning between those two. And then a translation would just change its distance, it would move, I should say, the image to a different location. And we would see the same orientation of that original image. So if you look, this is a translation because it's just been moved. It's like this pre-image was just moved over here. So we can start by identifying it as a translation. So now you need to give me a distance and direction. So what I would do, it's pretty simple. I would choose one point. It could be A, B, or C. I'm going to pick A. And I would trace that one point to the corresponding A prime on the other image. So let's just go horizontally first. So from A, I'm going to count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I moved 12 to the left. Then I'm going to count up. 1, 2, 3, 4, 5, 6. So I moved 6 up. So there's a couple ways you can give me your final answer here. You could tell me, well, first of all, you definitely want to say translation. And you could use the language 12 left and 6 up. I'm okay with that. But what I would prefer to see is that we can write the rule. So if I think about this, if I'm moving to the left, on my x-axis, I'm really going to the left 12. So that's like saying, x minus 12. And we could even just look at the original coordinate of A, subtract 12 from it, and we should get the coordinate, the x coordinate for A prime. And then the other thing that you could tell me, and sorry, we don't want to close our parentheses yet, is that we could say to go up 6, that's the same as y plus 6. Let's move on to question 10. So 10 is a lot like 9. We're identifying a transformation. Again, we want to make sure we include all of the specific information depending on what type of transformation it is. So in number 10, again, the first thing we want to do probably, actually, the first thing I might do here is just identify what type it is because it should stand out. This is definitely a dilation. We said that a dilation will make something larger or smaller. Like if you've ever been to the eye doctor and had your eyes dilated, your pupils probably got very large. All right, so we know it's a dilation because that's the only transformation that produces a change in size. All right, so now if we look, the next thing we want to do, and this is crucial, we've got to figure out which of these is the pre-image and which is the image. So I'm looking to see which is just marked with A, B, and C, and which is marked with A prime, B prime, C prime. So what I'm observing is that the triangle on the outside is the original or the pre-image. All right, that means that the triangle on the inside is the image. So what I mean by that is that the triangle is shrinking. It's growing smaller. It's going closer to the center of dilation. So if we look, we can, let's see, I would start with the points on the axis. We could trace A, and really what we could do here is we could follow A down and then follow B to B prime, and it's easy to do there. Now we could follow C. It's harder to do this on the diagonal to kind of imagine the path of C to C prime. But where these three lines intersect, that's going to tell you the center of the dilation. So right now, we know that this is centered at 0, 0. I might just write that down somewhere, or you could use the words the origin. All right, the next thing we need to do is figure out the scale factor. So this can be a little more challenging on a dilation where the image is smaller than the pre-image, but it's really not that bad. So let's just start with, I'm going to look at A and A prime, and the reason I'm choosing A and A prime is because they're on an axis, not like C and C prime, which those points are not on either axis. So what I might do is I might look at the distance from A to the origin, and I might count and say that I'm just going down 1, 2, 3, 4, 5, 6 units. So that original distance is 6 units. Then I'm going to look at A, and I observe, A prime. The distance from A prime to the center of dilation is 2 units. So really, what I'm trying to figure out here is what number can I multiply 6 with that will give me 2. Well, I know it's got to be a number between 0 and 1. So really what we could do is we could work backwards, and I could say, what number do I multiply 2 by to get 6? Well, I know that 2 times 3 is 6. So if my scale factor going the other way, so if my small triangle was my original, my scale factor would be 3. So I can just take the reciprocal of that, which is 1/3, and recognize that my new image is 1/3 the size of the original pre-image. And actually, let me restate that. I think the way I said that was inaccurate. The lengths, the side lengths of my original image or my new image are 1/3 of the pre-image. Because when I say size, I'm probably referring to area, and we don't really need to have that discussion right now, but the area is not 1/3 of the original. Okay, let's just confirm this. Let's make sure that 1/3 is our scale factor, and a way we could do that is just checking another pair of points. So I might notice again here that from the center to B is 6 units. I'm going out, and from the center to B prime is only 2 units. So again, 2 is 1/3 of 6. Now we could do it diagonally. We really don't want to work with diagonals, but we could at least check either the horizontal or the vertical lengths distances for C and C prime from the center of dilation. So from my center, I'm just going to go, Let's go horizontally. From my center, I could go out 1, 2, 3 to get to C prime, and I'm only moving over one space to get to, excuse me, C prime. I should have said C before. So again, 1 is 1/3 of 3. So we've confirmed that our scale factor is 1/3. All right, so our final answer, or what I'm looking for here, is the word dilation. I need you to tell me it's a dilation. You can tell me the scale factor. I'm okay with if you abbreviate SF. The scale factor is 1/3. And I also really want you to tell me that it's from the origin, or you can say 0, 0.